Today we're here to talk about the combined method according to RCSC 2020, and we're going to cover some of the most common questions as well. Hi, Keith.
Hi, how's it going?
It's going great. Thank you for coming today
Thanks for having me.
and talking about some combined method with us.
No problem. I think this is the first time you've actually allowed me on one of these.
Yes, allowed is the key word.
All right. All right. So
No,
what kind of trouble am I in?
and we need your knowledge.
right.
You're so good at explaining things so that people can understand it in multiple ways. So it's a pleasure to have you here to help me get this news and information and education out to everybody. So thank you.
No problem.
So as we stated, we're going to talk about the combined method according to the RCSC
Okay.
2020. We're going to talk about installation, but we can probably throw in some PIV stuff in the midst of that. But let's make sure we mention PIV when it pertains to PIV as well.
Okay.
So kind of explain the steps of the combined method for us.
So it's really similar to the other methods that are in the RCSC. There's an initial step, which we're used to calling snug, and then there's a final tensioning. So the initial step is actually called initial tension with the combined method. So it's a little bit different. And then there's the final tensioning phase, which is still very similar.
Yes. And so let's talk a little bit about the initial tension.
Yep.
When we talk about that, it's a torque that's applied.
Yes.
Okay. And where does that torque come from?
So yeah, there's an initial torque that you apply to get your initial tension. And there's two places it could come from. It could come from the manufacturer if you're shipped an assembly, a bolt assembly that has an initial torque from the manufacturer, or it's something that you use the RCSC spec to determine for the bolts that you're using.
Great. And in the RCSC, it does mention that we need to apply it to the nut. Now, is this something that we have to do just to the nut, or can we, because in some instances and in some cases on some projects, there's some minimal clearance issues. And in certain cases, depending on what the bolt is and what method it is, you're allowed to tighten from the head side. Are we allowed to tighten from the head side on this method?
No, because you're using an initial torque that's determined in a Skidmore. It's verified in the Skidmore in your PIV to turn the nut. There's really no way to duplicate turning the head in a Skidmore, and that's the difficulty. So your torque is going to be different turning from the head side versus the nut side. There's the difference in perhaps you don't have a washer under the head of the bolt. The dead load of the structure could be sitting on the bolt, so you're turning friction against that weight of the self weight of the beam or whatever the bolt's going through. Yeah. So no head side torquing in this method.
And that's great to point out, because I know that's a common question that people do ask. And the other thing is too is when we are doing this initial torque or this initial pretension, or what do we just call it?
Initial tension. Yes.
Okay, glad I caught that. So after we do that, what would be the next step that we would suggest?
Match marking. So you don't have to match mark. Just like in turn of nut, you don't have to match mark, but it's in the installer's best interest to do it. It's a small amount of time that will save you a lot of headaches in the future when it's time for quality control, quality assurance inspections. It is not worth it to not match mark.
Makes sense. And then when we educate people on how to do the match marking, we always say half of the bolt onto the nut, onto the steel. And then typically we call it an inspector's mark, a show-off mark. You don't even have to do that. That's just something, on the steel. That's where the final rotation would be. You don't have to do that one, but we typically say, this is something that's very helpful and useful.
Yeah, and that's in something that different companies have different processes and procedures they use. So yeah.
Yeah, and when we mark that, or when we determine the final rotation, when we're doing the combined method, it's a little bit different.
It is. So it's that your rotation in the combined method will be less than what you're used to using in turn of nut. And it really, the two methods are targeting the same tension in the bolt. It's just that the combined method intentionally starts at a higher initial tension compared to what your snug would be in turn of nut. So turn of nut snug, you're probably around 25% of tension. In combined method, you're targeting 45%.
Okay. So that would make the rotation less than what it typically would be at. Okay. So if we were just doing an installation, that would be it, because we would do that final rotation.
Yep.
That would be getting it to the pre-tension where it needs to be.
Right.
If we were to do a PIV on the Skidmore, what would that final step be?
Same as every other method, you're looking to make sure you got that PIV tension with your installation.
And that is indicated in the RCSC as well,
Yep.
according to the bolt strength as well as the bolt diameter.
Yep.
Okay, great. So the other thing too, one of the questions that always comes up because of larger bolts and being lubricated, and can you do that with this method? Can you lubricate your bolts?
If they come from as a matched assembly from the manufacturer, then no, that you can't relubricate them. This only the manufacturer can, because they're essentially telling you what the K factor is, what that initial torque is, and so that only the manufacturer can do that. If you are essentially becoming the manufacturer and putting a match bolting assembly together, a nut, washer, and a bolt, then yes, as long as you treat them the same way, you can lubricate them in the field.
That's perfect. And I think too, we should probably talk a little bit about the different types of bolts and bolting assemblies for this method of installation as well. So if you don't mind covering some of those.
So the standard F3125 bolts, the A325s, A490s, those can be supplied by a manufacturer with a specific lubricant, and they can give you a K factor and a initial torque for those bolts. It could be a specific type of bolt, like the fixed spline bolts, the F3148s, that they will also come from the manufacturer with an initial torque. So those are the two that can come from a manufacturer. They could be standard bolts, or they could be specialty manufactured bolts.
The other question that we typically hear or get asked is those splines, the bolts that have the fixed splines on them. Typically when inspectors coming to look, they see like a TC bolt that looks very similar to that. That spline, when it's reached its tension, twists off, right?
On TC bolt, yeah.
So these ones are fixed. So how are the inspectors going to know that it's where it needs to be and it's up to tension?
So the inspectors, just like with any other bolting project, would be involved in the bolts that are brought to the job site. They would have looked at the heads to make sure that they are the STM spec, that they're supposed to be the fixed spline spec. From the ground, they can't see that. They'd have to go up and actually look at the heads of the bolts that are in the structure.
But typically they're already there when they're doing PIVs and monitoring all of that anyway. Right. So they should already know.
They should.
Yeah. So how do they know that the nut itself has been turned to tension and brought up to full rotation that it's required?
So there's differences in the RCSC. If you're not using match marking, or in AISC, if you're not using match marking, there needs to be they use different terms between RCSC and AISC, but the inspector needs to be there watching the bolts being installed, not all the time, but just to make sure that they're doing it properly. If they are match marking, the inspector can come after the fact and just look at the match marks.
Awesome. Okay. Thank you for that. And the only other question that I can think of is there any instances where you can see this being a good fit, or any instances that you see that it wouldn't be?
I mean, it really is up to the engineer, the installers, the owner of the project. It's all these methods can be used properly, and all of them can be used improperly. It is sort of an extra level. I can see inspectors liking it because they can now sort of inspect snug where there really wasn't an inspection besides tight iron before. Is it necessary to have that extra level of assurance? That's really up to the engineer whether they want it or not. But like I said, with any of the methods, bolts can be installed properly and without a problem.
And it just comes down to education.
Yep.
And doing it properly.
Yep.
Awesome. And that's why we're doing these, right? Well, thank you for sharing your knowledge with us today.
No problem.
And I appreciate you being here.
I appreciate you having me here. So we hope you enjoyed our conversation today. If you did and you have other topics in structural bolting you'd like us to discuss, please leave them in the comments below.